Yeah. Hello, everybody. Welcome to my talk about locked skyboats. Um, Try to make a joke here. I don't know if anybody recognizes, but it's from XKCD. So the thing explain are using only 1,000 words of the most common 1,000 words of the English language. Um, I'm not gonna do the talk in that way. Don't worry. I'm gonna use normal words, and it's gonna be all normal English language, I hope. So I'm Ben. I'm going to introduce myself in a little bit more detail, but basically to start off with, I have this quote about aviation. Um, I guess somebody might recognize who did it. Is there anybody who knows? Can you raise your hand, maybe just? You don't have to, or you can shout the name of the person. Nobody. So basically, electric supersonic VTOL hard problem was set by Elon Musk. And VTOL, I try to not use abbreviations in this talk, but just on the first slide I had to, because it's a quote. So VTOL, vertical takeoff and landing, basically is this next generation of aircraft. And as you can see here, people find this not too easy. Like, people find that building a VTOL seems to be like a really hard problem. A year later, same person said this. No, I think it's incredibly difficult to bring an aircraft to production and meet all the regulatory requirements worldwide. It's a very difficult thing. So you can see there's like this person who basically made electrical vehicles, like cars, available for everybody, who introduced spaceflight and reintroduced spaceflight in the US as a really big thing. But he is saying, aircraft? No, I won't touch. And over the next years, there were more quotes, but I just want to keep it like that. And like, yes, it is difficult. It seems to be difficult for most of the people. It seems to be not approachable. It seems to be like a problem which is really, really hard to solve. So everybody knows this car? That's a DeLorean from Back to the Future. It literally was a VTOL in that sense. It was a car which could fly at some point, a vertical takeoff and landing, so it didn't need any runway, or you don't need roads where you're going. Yes, it was a time machine as well, but let's not talk about this. Like, this is a different topic. So looking back at what Elon Musk says and like this quotes, this seems to be like some dream, some unsolvable thing. But is it actually? Is aviation so hard? And like, is it such a difficult topic to address or like to deal with or to work in? It all comes back to the dream of flying. So coming back to XKCD, I mean, what else would you expect? It's the dream of everybody to like, at some point, like, you keep running and at some point you just take off and you can go wherever you want. And it's like getting from point A to B, like the direct route. Like, you can go like directly from here to Oslo to Copenhagen. Like, you don't need to like take the car somewhere like up Norway and down again or stuff like that. You don't have to cross water in that sense. So you just like go from A to B. It's three-dimensional. That sounds fun. I mean, like going up and down and not just like left and right or straight. They seem to be like, quite unreachable for a lot of people as well. Like, it's like this. It's a little bit like gazing at the stars and thinking like, how do I get there? Like, how can I reach it? And planes, I mean, they are closer. You can see them at airports. You can get on them on airports. You can fly with them. But still, like, how do they work? What is it behind it? Why do they fly? That's all like kind of, for most people, mysteries. And obviously, it's fun, adrenaline, and like the feeling of freedom. And I mean, there is the simulator upstairs. I haven't flown it yet. I was considering to skip my talk just to take a chance, but here I am. But I guess it's worthwhile to check it out upstairs. Probably it's fun and some adrenaline, considering it's like a military aircraft. But who am I actually? Like, why do I talk about aviation? Why didn't I actually mention cybersecurity yet? Like, and why am I called CyberBen? So that's me. Or maybe that was me a while ago, like 30 plus years maybe, I don't know. You see, I grew up in a time where you didn't really have a computer at hand all the time, so there were still analog things. I've been running away from reality since the late 90s, 80s, sorry, that was when I was born. You can see I've been living in a few countries, like across the globe, you could say. I mean, New Zealand was the furthest I was getting. And that's just living in these countries. I've been traveling much more than that. I claim to be educated in flight controls, skyboard computers, and security. What does that mean? Basically, I studied avionics, so I have like a degree in how to actually build aircraft systems. I have developed my own like navigation system for like artificial aircraft, like in a whole group project with like 90 students and engineers. I know flight controls. Yeah, I know how to fly a plane. I've been flying a few types of planes. I have a few, like 8 or 10 flight lessons on a helicopter. Don't try this. That's just crazy. It just wants to crash immediately. And yeah, I also studied security. I started off like studying embedded security and specializing in this area, kind of merging the topic of the computers on an aircraft as well as like them being embedded system, the security of them. Probably not the right phrasing, but role-playing experience in a corporate environment. I've been consulting a lot of aviation companies. I've done things on the technical side. I've done risk assessments. I have managed a team of aircraft security engineers at a manufacturer. Like, I've been around quite a bit, and I can tell you, having seen the talk before about mental health, aviation and security is not a healthy thing by itself, but it's manageable if you just start focusing on the right things. And nowadays, living close by, I mean, there's somebody from Tallinn, I guess. Some more. Yeah, but I moved to Tallinn because Finland was a little bit too much of people around me, like the first row, kind of. And somewhere over there, some more people. Like, I've been living in Finland before, working for this company called F-Secure at that time. But now, yeah, I'm living in Tallinn, and I'm actually having my own company. So nowadays, I'm consulting for like aerospace companies by myself, because it is a challenging topic. There's a lot of companies around, and the best way to do it is to just go ahead and build up your network and like do it by yourself. So yeah, I kind of claim I know this world of aviation and also like the security world. So I've been working in this domains, like both of them, for a while, and I've seen a lot of things in a lot of companies, countries. Some of the stuff you don't even want to know potentially, but if you ask me nicely and I can talk about it, I'm happy to share any insights or experience. So the news, you always have to kind of like draw a picture on like what is actually aviation and cybersecurity and what is actually like publicly known, what are people talking about. There's the usual news is about like plane hacked, airport hacked, airline hacked. The new one, really like fancy, is pictures sent via airdrop. Like passengers sitting on the aircraft just looking for like iPhones which are open to receive images and just sending them out. There have been like normal pictures being sent, selfies. There might have been some pictures about bombs being on the aircraft or stuff like that, which you don't want to have on an aircraft which is about to take off, because passengers don't like that. Then there's this usual statement, like, which comes from a lot of people. Regulations are changing too slow. It's like, why is there no security on old aircraft? Why don't we see what is being done in security in aviation? But if you're actually like working in this area, you know what's going on and what is being done. But the news are the news. And then this usual ransomware at tier 2 supplier, like some supplier from the aviation world having been attacked by some sophisticated hackers who encrypted all the hard drives, which was at the end just a simple mail attachment, and somebody clicked it, and then it just happened. So today, to actually help you a little bit to understand what this aviation cybersecurity is, what is aviation, how does it work, how do we get from a drawing of an aircraft to an actual aircraft, and how does security actually fit in there? So basically the engineering perspective, like the cybersecurity engineering perspective, I try to bring it to you, like open it up for you, and give you an idea what this actually is about. So we're going to talk about skyboats, like the aircraft, like why they fly, how they fly, how they change after a while, or like how they're being improved. And yes, we're going to talk about crash it, but it sounds bad to actually put it out. So it's not that official that we're talking about crashing aircraft, but there might be some information about it. Then we have like building the skyboat. So basically building the aircraft, like what components do you need? What kind of systems are being involved in like building the skyboat? And like how do you test it? How do you break it? Things like that. So basically end to end, like where does it come from? Where does it end up? And then there's like some security around like how is it actually being isolated, secured? How do you actually test on an aircraft from a security perspective? As well as how do you, when you operate the aircraft, how do you manage it? So draft it, build it, test it, break it. Again, a quote from a random person from the internet. I have a QR code later for him, I think. It's a nice YouTube channel about a person from America who's building aircraft. But fasten your seatbelts. Nobody has them, but literally, let's go into the like more technical, more interesting part of it. Abbreviations. My day-to-day. I would assume most of you people recognize maybe a few abbreviations. I'm going to have now like 15 slides with abbreviation explaining like the terms. So bear with me. No, just kidding. It's crazy if you know security abbreviations and then you go into aviation. You have 3 times the amount of abbreviations, and every manufacturer, every supplier is naming the system in a different way, even though it's the same system. So don't want to scare you with this. I'm not going to talk about it, but this is the reality. This is where it is. This is what I deal with on my day-to-day, talking to manufacturers, suppliers, airlines, whatever. But yeah, there's not going to be 15 slides with these. Like the VTOL was the only abbreviation, I hope, in the slides. So let's start with the first point, fly it. So again, just to reconfirm with you, trust me, I'm an engineer. I've been working for a certain manufacturer before I started my own business. So I've been working actually on VTOL aircraft. I've been the manager for cybersecurity there. I've been running the whole team, setting up everything which is needed for security. So yes, I've been around there. So referring to this talk which is coming after me about the maritime world, boats float on the water. That's a fact. I mean, if you look at a boat, it floats. It doesn't sink. So same applies for aircraft. They float on the air, literally. It's just another liquid. So there we have empirical evidence. If you're wondering why planes fly, I'm not going to explain it to you. There's a lot of physics about it. This is just how we have to deal with it right now. That should be enough for us. If somebody wants to know more about it, that probably would be one of the points where I would say, please don't ask me to explain it to you. I studied avionics. The flight dynamics and everything behind it, depending on the aircraft, I don't even want to know why they fly. And if you look at these big Beluga aircraft from Airbus, like the ones which can open up on the front, even the engineers at Airbus sometimes said, like, yeah, we don't even know why it flies. It just flies. We are lucky. And obviously, aircraft are not alone. There's a lot of network communication between the aircraft. So you can assume that these nowadays are well connected. And that's necessary. So maybe to take a little bit of the magic out of it, why they fly. This image, you see, there's a lot of magic involved. That's, if you ask me how they fly, this is how I would explain to you why they fly and how they fly. How do they change over time? So kind of the first aircraft, first flight, Wright brothers. So we have moved on from there. We have changed the aircraft quite a bit. I mean, I don't even know if this had an engine. I think there were like 2 propellers. That's about it. And I wouldn't argue that this is flying in a sense of nowadays, because it's more like, yeah, you're gliding above the ground. You're just lucky that you're not touching it anymore. So you see nowadays aircraft, like I said, they have to communicate. So there's a lot of increase in connectivity. We have gone from where you actually ping the aircraft, and based on the reply, the aircraft knows where it is. That's how it started. Nowadays, there's GPS, there's Galileo for Europe, There's internal sensors who calculate your position pretty precisely for quite a long time. It all improved, and it all connected. I think in Europe, or at least in Germany, as far as I know, like nowadays, you don't even have to turn off your phone anymore on the aircraft. So flight mode, is it still necessary? So we are changing constantly. We are increasing the connectivity. We are connecting more and more systems. This comes as well with automation. Usually, I would put this picture of like an old Concorde aircraft where you can see you have two pilots, and then you have the flight engineer, and then potentially you have the radio engineers. So you used to have a lot of people in the cockpit responsible for a lot of activities. So not a single person was responsible for it all. That changed. Then, which is directly related to the flight crew reduction. So basically, we are nowadays at this point, in theory. So just one person sitting in front. We trust him to handle any situation. And I mean, to be honest, most of the time, who's flying the aircraft? Like, I mean, the pilot is doing takeoff and landing, and besides that, there's like one knob he maybe has to turn. And that's about it. Is it still like this big job? And then look at incidents which are happening, or look at things which might happen in aircraft. So what happens if a system fails? So the pilots, they're supposed to know their aircraft really well, because if a system fails, they have a checklist how to react to that. But that's like quite a challenging situation to be in if you're like close to landing and like it says, oh, the landing gear doesn't go down. Would you be able to manage like saying, okay, I have to keep flying, I guess. Oh, I have to tell somebody that I keep flying. And where do I actually go now? Because I was supposed to stop at this end of the runway. Like, how do I do this? So even though I say as a title, improve it, is it actually improvement, or is it just like putting all this automation in it that actually the human factor kind of is being removed or neglected? Like, we will maybe see. Digitalization, a big word, can mean a lot, and like every other industry, it's happening in aviation as well. Like, you have your phone app with your boarding pass when you go to the airport. You don't print anything out. Like, the flight plan is being transmitted automatically to the aircraft. Like, it's just a matter of sending some bits over. Pilots used to have this big trolley, like with all the handbooks and all the paper, which was like 20, 25 kilograms. They had to carry it around, but as you can see in this bottom picture as well, maybe like on the left-hand side, basically, that's a tablet. And all the information is on a tablet. It's all digital nowadays. There's like barely any paperwork being done. I think the most likely thing for like a plane on an airport where paper is transferred is when the pilot gets the weight and balance information. So basically, how many passengers do we have on board? How many luggage do we have on board? To calculate what do we need to take off at the point where we need to take off. Because if you are too heavy on the front and you try to take off, your aircraft doesn't want to go up. That can be quite bad. And then the fancy word of e-enablement. So basically, and I'm going to go a little bit more into detail when I go more on the engineering perspective, is that the systems on the aircraft are getting more and more integrated. So it used to be this really random boxes, or like a lot of boxes with different systems that looked like a mess. It took a lot of space, and nowadays with e-enablement is kind of more integrated. And also, again, the E in e-enablement doesn't stand for security, but for connectivity. I don't even know what it stands for, to be honest. So let's not talk about crashing an aircraft. Crashes are definitely not anticipated in aviation. I mean, they put numbers on it. Like, there's this nice number of 10 to the -9. There's talking about catastrophic. So, like, I don't want to say it's anticipated, but based on like the calculations, at some point an aircraft will crash, and we have seen that. But it should be so low that like whenever you're doing your maintenance activities and follow the processes, that at the end, like, it's really, really unlikely that a plane will crash because a system fails. And this is like really about the systems on board. This doesn't calculate human factors into account, like, so it doesn't anticipate a pilot going crazy on an aircraft or things like that. But yeah, like I say, I'm not going to call it anticipated, but there's numbers which are used to actually, like, yeah, to accept it in a way. And also, not about talking crashing it necessarily, but you would be surprised if you fly, especially like on the regional flights in Europe, like when you fly with an Airbus A320, 1921, whatever, it's the same aircraft at the end, just different size. And then you fly with an A320neo, it's actually the same aircraft. Even on the A320neo, you could find floppy disks. Because what did they do? They just used the old aircraft, put new engines on, gave it a new name, it's more efficient. Here we go. There might be some more changes than just the engine, but it's literally says next engine option, which is like, yes, or new engine option, so it's a new one. And the same with Boeing. 737, 737 MAX, 737 NG. And I mean, it's sadly fitting on this slide when I say crash it, but the MAX incident on the Boeing topic, that's kind of like where all this engineering plays a role, and maybe you might understand more later how the Boeing incident, if you're aware of that, like the 737 MAX issue, actually really relates to the engineering process which is being used in aviation. And obviously, like I said, like you're learning a lot from these kind of events, and this picture from World War II is kind of like also showing like what you might not learn, because this is about like aircraft returning from the war, and like you can see the red dots are like the positions where the aircraft were hit. And basically the first idea was like, oh, we have to make it stronger where the aircraft actually was hit. So actually where the red dots are, this is where we would improve the structure of the aircraft. But at some point they realized, wait a second. So we only have aircraft returning with like dots at these positions, but we don't have aircraft returning with actually hits on the other positions. So what happens to them? Yeah, they literally don't come back, they crash. So instead of improving where the dots are, you actually go at the things you don't see, because you have to like put it in the context. And that's also like how safety works. Like, I mean, you learn a lot like from what you see, but you also have to anticipate what you don't see or what might not be reported. So when a pilot reports something, like it really needs to be investigated and looked at and like understood like what's the root cause of this and how can we improve this. So let's go into like a little bit more engineering. Actually building an aircraft. So basically, let's just use a Lego aircraft as an example. Just imagine like each brick is like one component of an aircraft. And to make it really sound simple, you just put them together and at the end you have an aircraft flying. Easy. But you have to find the right blocks, because you also have to be able to fly. It has to like work together, it has to communicate, so basically interfaces have to fit. And yeah, if it doesn't fit, maybe you have to build some new blocks. So, I mean, in the Lego example, just get a 3D printer and print the part. But in like engineering perspective, like you have to potentially develop a new system to meet your needs or like your concept. And yeah, you can do it the fun way if your skunk works and you don't care about pilots returning. So that used to be like the really fun engineering part, when you just start playing and put people on a plane and yeah, they don't return. OK, move on, next one. And then, and like I said before, like pilots carry a lot of material when it comes to manuals. You have to put it all together according to how you want to put it together. So you basically have a build manual, an operation manual, like to actually like build it and operate it. And it's not rocket science, it's aerospace engineering. So, I mean, as difficult maybe, easier, who knows? So how do you start like with these building blocks, and like where do you take them from? So you start with an idea. So you say, I want to have an aircraft, like Elon Musk says, supersonic VTOL aircraft. So what do you need? It needs to be able to fly. It needs to go fly supersonic. Oh, and yeah, probably it should be cheap and electric. So let's just put it together. It's going to be fine. Or you say, like Boeing and Airbus, OK, Airbus has a new aircraft. Ours is not as efficient, so maybe we have to put new engines on our aircraft as well. And if you want to do it fast, you just put a building block on the aircraft and you say it fits. The 737 MAX, this definition of it fits was quite a gray area, to put it lightly. At the end, like it didn't fit in the same manner as it should be, so like there was not mature enough evaluation of that. Surely, this supersonic electric VTOL is definitely not realistic. So obviously, like a product should have a market. It should be being done in a certain time frame. You should have the right resources, the right money, stuff like that. And it's not just a one-person job. So it wouldn't be like that one person sits there and says like, oh, this is my idea. Now I have an aircraft. It's basically a lot of competing engineering teams. And like I said, I studied avionics. Actually, the avionics group is, if you go to the middle of the second but last, that's basically how an aircraft would look like from my perspective, if you can see it. But it has a lot of antennas, a lot of like technology to connect and like to compute things. But if you then look at other things like the maintenance group, you just have a lot of ladders attached to the aircraft, so people can actually work on the aircraft. So it's not a matter of like there's just one person or one team wanting to have a solution. It's like a really big group of people. And sadly, this picture doesn't have cybersecurity yet, because that would be funny as well. I guess I would just put the aircraft in a Faraday cage, and I would be fine. So yeah, it's a lot of teams working together. And the thing is, from my perspective, you don't need to know it all. Like, it's not like you need to know why an aircraft flies. It doesn't need to know like why we choose this engine. Like if you do cybersecurity, it's important that you know where your area is, where you need to have an impact and where you need to be involved. Building it, like I said before, take the right bricks, like put it together, and oops, again, doesn't fit. Redo, start again. Like it's an iterative process, and you will see at some points that things not fit or doesn't work out, so you go back a step and do it again. But that's like the process. It's not just like a straight line and going from one end to the other. It should be fail-safe. Like we talked about this crash in 10 to the minus 9. Like it needs to be a safe design, so you need to trust it that it goes from A to B in a way which is accepted by the industry. How do you do that? A little bit of avionics. FCC. Damn, I have another abbreviation. I didn't want that. FCC is flight control computer, basically the system which is controlling the engines as well as the actuators and make sure that like you fly level or you turn right and left, go up and down. As you can see, if you want to be in the red area with like your failure rates, like having a 10 to the minus 3 or whatever with like errors or failures of a system, you put one flight control computer and you will be pretty sure that it fails quite quickly in a sense of like flying hours. So what if you put 3? Oh, that looks better. That's like this orange part where like, it's acceptable in a certain way, but it's actually not enough for aviation. Like you have to be in the green area. So you can see you have redundancy again. You have 3 systems, but you can also see that one box is green. In this sense, like if you can't read the text, it's basically about like dissimilarity and like actually having a different system being built. So you're not just building a flight control computer 3 times and put it on the aircraft. You're actually building the flight control computer twice. So you put different engineering teams and say, oh, you're building this flight control computer with this software, and you're building it with that software. And then you have this dissimilarity. So like if one system fails, it's unlikely that all 3 fail, because the same error might not be present in one of the other flight control computers. And yes, this can be done by code. This can be done by hardware as well. I mean, just put a different CPU, things like that. And I don't see this picture actually on my laptop, but this shows the evolution of this avionics. Like I said before, you had like these boxes before, which like just were one system, and they represented just the flight control computer, for example, or just the flight management system, or just the navigation system. And like this time, the evolution of these things, or like these systems, is that actually you start to put them in one box. So you have multi-core computers. It's kind of still the future of aviation, multi-core computers, but there's approaches to actually say, we have one box, multi-core, we can run 2 or 3 systems on it. One might be safety critical, and then we have 2 or 3 systems which are just providing entertainment to passengers or something like that. And some people who have done aviation might think now, oh, you're putting the flight control computer next to the entertainment system. This is where all the passengers connect. Interesting. So security people would be like, oh yeah, I can just jump over from here to there, and that's not going to be fun. And again, human factors. all these designs is like from a perspective that, oh, we trust the people who are involved in these processes. We trust the pilots, we trust the engineers, we trust the maintenance teams, we trust the operators to do the right things for security. But if you come from security, well, you probably know that like humans, trusting, maybe not so much. So it's something which, from my perspective, like the industry is still catching up on, like, because for them it's like, oh yeah, we just trust the human, and then just ask them like, okay, but if I would like hack your software development environment and like put code in there, would you see that? Maybe. Okay. What if not? Maybe not so good. So it's something like which there's a lot of trust built on humans right now, and that's kind of like a challenge by itself. Security a bit. Like I said before, putting flight control computer together with an IFE or in-flight entertainment system, you don't want to do that. And this is where this isolation comes into play. So basically what you're doing is you build trusted environments where your safety critical systems are, and all the other stuff, like the open domain, basically is far away from that. Oh, not far away. Securely segregated from the trusted environment. And yes, that's going to be boring for some people, considering there's mostly technical people here. You do risk and threat and risk assessments. You go through a whole loop of like seeing what could be done, who could do it, when could they do it, what is the risk related to that. But this is how you actually evaluate it from a security perspective. Like at the end, you want to have green colors for security in a way. And yes, the Swiss cheese model also is being used in aviation. Like most people know that properly, but don't have a single point of failure, don't have a single security vulnerability which could bring you to the trusted system. So just really basic, if you would like go from left to right, on the right-hand side you would have the flight control computer, and on the left you would have the public domain, like the in-flight entertainment system, the Wi-Fi of the aircraft. And if you look on the aircraft, you would see that actually like there are several security controls in place between these so-called domains. And yes, don't overdo security. It's already challenging enough to integrate it with safety and not impact the safety. But if you're doing too much, we're still talking about real-time computing systems. So the aircraft wants to have the information quickly. Like if you're turning banking right, whatever, and there would be some miscalculation, you want to know, or like if you're like realizing, oh, I might flip over, you want to know it early enough and not like 3 seconds later when you actually can't control the aircraft anymore. So yeah, don't build a Swiss Army knife. Build an aircraft. Yeah, just to summarize these a little bit, like safe design is not equal to secure design. But you could imagine talking about this dissimilarity in flight control computers, that this also actually helps security perspective, because the same applies for vulnerabilities. If I have a vulnerability in one system or one computer, but I know the other two are actually different, this gives me some leverage to work with. This is something I can use for security. You want to have it end-to-end. You don't want to have like some points where it's like, oh, we're getting our software updates on a floppy disk. Thanks, not anymore. That doesn't work. You need to improve it constantly. I mean, with time, the threat landscape changes, so you need to have something in place to actually improve your systems or like make them secure again. I don't want to open that box about changing a system because that's a long process. It's not fun. Better have defense in depth. If one vulnerability shows up, once one layer of security fails, you can still rely on the rest of it. And the most boring part, obviously, document it. A lot of paperwork being involved, a lot of like assessments, a lot of test plans, things like that. It's fun. But hey, at the end, you might get to fly an aircraft. Try it upstairs. There you probably can do something like that. And you don't feel the same as he does. Security testing, or no, flight testing actually for now. It's extensive. Like I said, like you need to actually have test plans, which, like I've seen them at Airbus. They can be hundreds of pages easily for a single system, a single functionality, and you test all the things through when it comes from safety perspective. And the same nowadays, obviously, for security. You need to exploit the limits of the product. So, I mean, you shouldn't do that with an aircraft you're building, but you actually do these kind of tests. So this is how you test a wing. Have you ever seen an aircraft wing bending that much? Probably not. but this is what they can actually do. So if you ever fly an aircraft and you see the wing doing a little bit like this, don't be scared. That's what they can do. And I put it on the wrong slide, actually. Like I mentioned, like this test it, build it, break it, repeat before. Like that's actually a YouTube channel about a person who's building his own short takeoff and landing aircraft. He's doing fun stuff. He is over-engineering a lot, but it's a nice perspective into like, how do you actually build an aircraft from scratch? And he is actually building them from scratch. He's building all the parts of the aircraft from carbon fiber by himself. And it's crazy like what he does. And definitely recommend it if you want to know more about like how to build an aircraft from scratch on like a more human level than what the big aircraft look like. And security testing is fun. Knut, can you please nod? Thank you. But is it really? Is it even fun if you're sitting in a Faraday cage or like spending a whole night on an aircraft without AC on somewhere in the desert? Yes, keep nodding, thank you. I mean, like, how do you actually approach security testing for an aircraft? It's kind of challenging. If the aircraft is already operational, that's a challenge by itself. If you just have a prototype or like a development aircraft, it's actually easier. The biggest challenge is, what do I need to test and how do I test it? The Faraday cage is there for a reason, because with connectivity comes systems which you don't want to expose, or like you don't want to do the security in public because you don't want to do GPS jamming at an airport. It's not, I mean, it's fun, but not for everybody. So yeah, it really depends on like what you need to test and how you can test it, but it's like getting more and more complex, and yeah, get the right environment and get the time in. Like engineering follows a strict time plan, so if you don't allocate the time early enough, no. And like I said, time is a factor, so you need to manage an aircraft while it's being operational. So you have these hours until failure, hours until vulnerability. So like that's the operational perspective into like flying in an aircraft and how to actually deal with security. And you have to react. And there's ways to react. I don't want to mention regulations, whatever, but there's a new European regulation about like information security management. So Part IS is actually bringing all these stakeholders together to react coordinated to security incidents, and about sharing these kind of insights. Because you haven't seen many talks about aviation, I guess. That's probably for a reason. I mean, I'm not really aware of any security vulnerability that would impact the safety of an aircraft, like a real one, but there could be one. Even I don't know everything. And yeah, like, it's not risky to smoke next to gas, and I guess nobody's watching these anymore, like the safety briefings. I still listen to them and I watch them, because it is important. And sometimes I realize, oh, this aircraft is not like I was expecting it to be when it comes to leaving it. So yeah, just can recommend it. And yeah, it's not a unique product development lifecycle. At the end, you start at a draft. You assess like what you need to do. You consider what is being like required by regulations. But I mean, it's just developing another system in that sense. It's like, it's an aircraft, it's gonna fly, and it's hard in a sense, but it's not like rocket science, maybe. And the good thing about aviation cybersecurity, especially in engineering, is security is not necessarily a cost center, because yes, we want to do it, but also we have to do it, because if we don't do it, we can't fly. And like I mentioned before, security supports safety, or safety supports security, so they're not the same, but they are helping each other out if required. And for the sake of time, because I also want to do some Q&A, just shortly looking at like the product development lifecycle, you can see, I mean, this is the aviation one, this is based on a standard, but does it really look different for like other development life cycles? I would argue that you do the same. You have a concept, you do requirements, the detailed design, implementation, and then all the validation activities and testing. I mean, not a big difference. And I'm going to skip this part. This is more about like the operational side. And like I said before, like there is community, there is things happening, there's people talking, there is exchange of information about security events, and people actually are helping each other. So it's not like a private community. Yes, the regulatory twist, the certification always scares people off or companies off. Like Elon Musk doesn't do it because of certification requirements. But it's manageable. Like you just have to approach it in the right way, and you have to talk to these people as well. They're really helpful. And yeah, obviously, it's not just about aircraft. Like I've mostly tried to focus on aircraft in my presentation, but there's a whole environment around it. And they all need to do security at the end because, like I mentioned before, aircraft communicate, so there's connectivity. And also, you get parts from suppliers, and end-to-end security should be implemented. Like you don't want to have a software coming from a floppy disk and then you copy it to some Windows XP computer, maybe, if you still have one. And then you connect that to the network of your company, and then like it all goes crazy. So end-to-end is also really important. So how to get started? My recommendation is like exploit the opportunities. Whenever you get a chance to talk to somebody or a network or find an opportunity, go for it. If you're interested in aviation, just go. Go ahead, try out. There's nothing to do wrong. Understand and be understood. Listen to the people who try to tell you how aviation is being done, but also explain security in a way which they can understand and not scare them off. I have had situations where I was trying to explain a solution, and suddenly the next day the engineering team said, oh, we're not doing this anymore. We don't want to do security for it. So literally they, just by me talking to them, were too scared to do security and just skipped the whole system. And stay calm, stay focused, stay safe. I mean, don't go crazy. Don't burn yourself out doing that. It's a challenging domain to be in, like with all the abbreviations especially, but it's doable. And it's not just engineering. Yes, I'm an engineer, but security stuff, you don't necessarily need this kind of engineering background I have. And yeah, that's about it. If you want to talk to me, just approach me after the talk. You can ask me anything about building your own aircraft. I haven't done it yet, but if somebody's interested, sure. And anything else aviation, just approach me. Thank you. Any questions? So if you have some questions, could you please just raise your hand or stand up and wait for the microphone so that everybody can hear it? And I anticipate if you would just like ask it publicly if you have a question to me right now, because then everybody can hear about it and like we can share the answer. Was it that simple? Everybody understood everything?
Thank you for the presentation. So where does the magic come from?
From the right, and it goes to the left. Like it goes in the engine and then it just disappears.
OK, actually, I had a question about this automation and the security of what pilots actually do. I think there was recently a case, I think in Spain, where this pilot just decided to fly a plane into a mountain, just killing off everybody. Do you think like automation or like this kind of
so you mean the incident where like it wasn't a German airline, like where the pilot, one of the pilots was outside and the other one just crashed into a mountain, yeah. So basically, this is like where this iterative like evolution of the aircraft comes into play, because nowadays if you have a new aircraft or a newer aircraft, they actually have a system which is called Ground Proximity Warning System, GPWS. Basically, it would warn you if you are attempting to crash the aircraft, and actually it would at some point start to react automatically. So it would just go up. So it was an aircraft which didn't have the system, so the pilot was able to do it. And I wouldn't guarantee you that the pilot is still able to do it even though the system exists, because he still has to a certain level the power to overrule the system. So if he knows how to turn it off, doesn't matter. But this is a matter of like how much do the pilots still know, and with the Boeing 737 MAX it was the opposite. The pilots didn't know enough to react to that. And this is like where it's like a really challenging balancing act with like reducing more and more flight crew from the aircraft. Like the single pilot operation, which was shown in the picture, 10 years, 15 maybe, not before. It's going to be like too challenging to actually not have 2 people on board anymore.
In a not so complex aircraft, how do you prevent somebody of actually sending an ILS glide slope that is like 10 meters away and making the airplane crash?
Sorry, can you repeat the first part of it?
In a not so complex aircraft where different nav aids are not compared to each other, let's say like an old King Air, how do you prevent somebody with a transmitter actually not crashing the plane on sending a faulty glide slope?
The stupid answer I could give you is like nobody would get on the airport to actually tamper with the ILS system, but that would be the wrong answer. So it's kind of a challenging question, because I think you can't prevent it. I mean, it depends also on the like situation of the flight, because If it's a clear sky or like the night and you see the runway lights and stuff like that, the pilots would see it. If it's like the visibility is really low, no. And if you come back to me later, there's actually a research paper from EASA where they actually did this kind of simulation on a flight simulator with real pilots, tampering with ILS and all these things. And there's really interesting findings in there, but I can't summarize it like in one sentence.
Hi, thank you for the talk. I was thinking, what does a vulnerability assessment or a penetration test for an airline or for an airplane look like?
It really depends what you're looking at. Like, there's no simple answer to that. Like, if you like, the easiest example, I guess, to explain to you is like when you look at an in-flight entertainment system or the Wi-Fi on board. It potentially is just like, yeah, Wi-Fi security. There's a website, a web app, a web server, and this is like pretty basic security testing. But if you actually have some avionics or safety critical system, it really depends on the system and like what your threats are and what you need to look at. It can be simple code review. It will also be, especially like nowadays and with the move on like to more connectivity, you would actually have a test aircraft where you actually would tamper with the system on the aircraft in an isolated environment, and this could, like the testing, like that, it's probably too much for me like to summarize it in that sense, but anything you can think of basically. I mean, there's web apps, there's hardware, there's anything like from technology perspective you can test. This.
Hello, great talk. Thank you so much.
Thank you.
I have a question that is a bit of fun, maybe. Every time when you happen to be on an airplane and you have, the interactive interface in front of you, how often it is, or how likely it is that you can actually do any harm to the system? Because I guess the networks are segmented, so
I mean,
you
like,
shouldn't be able
if you
to
mean the system, the entertainment system itself, I
Yeah.
mean, you can make it crash, I guess, easily. But going then to the safety critical part, no, because they are isolated. Nowadays, they have basically data diode in it, so basically it's just unidirectional network traffic going from avionics to the in-flight entertainment system, and in old aircraft, basically, it's actually good to have old boxes in there, which are all isolated and only have unidirectional communication. So you actually couldn't even communicate with it in that direction. So it's unlikely. But
do you
yes,
think
you could
there-
crash it, but it doesn't affect the flight.
Yeah.
Like,
But do you think there are any planes in use that don't have the separation?
unlikely. I wouldn't say no 100%. If there's nothing else, nobody else, thank you. Or was there somebody else? Please.
Yeah, just a quick question. Like, I know, like, I have some background in aviation, more background in security, but like, how much penetration testing or testing of, for example, the data links, the ACARs and the others are being done, since some of the messages that they send or that they receive on the plane are kind of getting quite close to the more critical avionics parts?
Yeah, and there's not much being done, and I think that's something like where it's challenging for the aviation industry, like being in that sense like slow with developing the technology, because ACARS and all this stuff, or ADSB, for aviation, it's new and it hasn't been designed with security in mind, so not too much fun.
Yeah, exactly.
to work with.
And there's the duality that you kind of, especially for ADSB, you kind of want everybody to be able to receive it. At the same time, you would want to kind of prevent everybody from receiving it. So, yeah.
It's a challenging thing, and like it really also depends. Like, if you talk about ACARs, there's again the argument about human factors, and you would have the pilot to actually check the message. It would be a process to actually say the pilot has to check the message that everything is correct from his perspective. But how much does he actually understand it nowadays, and like how much time does he spend on that? So it's a challenging area to be in. There's one more at the back, Mr. Henry.
Hi, Ben.
Hi.
Nice to meet you again. So considering the EFBs need gate-link connectivity to get the updates, and gate-link as a concept is quite difficult to handle the global connectivity of all the airlines in all of the airports. How do you see the security of it going forward? How do you secure gate-link
So first of all, for everybody who doesn't know EFB, that's electronic flight bag. That's basically the handbook. Thanks for using the abbreviation. Seems like you know your stuff. So I might be wrong, but actually GateLink isn't used as much as you would assume. Not a lot of airlines actually use it. And I mean, the thing is like, it's like any other Wi-Fi. You shouldn't trust it in that sense that whatever information comes over it is trustworthy by default. So, and I don't know how many companies or airlines are actually doing that, but the integrity check should be independent from the interface in that sense. And I know companies doing that, and also they're having their own Wi-Fi and stuff like that. So GateLink is not the single solution actually for that use case. But yeah, don't trust the interface, but make sure that you have end-to-end security in place. It seems like that's it. Thank you, everybody. Enjoy the maritime talk. I hope it's more grounded than mine.